Testing, testing, testing. Testing, testing. Okay. Hello everyone, this is the midterm review. Okay. Hello everyone, this is the midterm review. Be doing all the tests here. The separate packet, I already have the answers attached to it, so I didn't want to spend time making that. I don't have an answer sheet in the classroom, so if you want to check it out, I'll make a copy or two and you can use it within the classroom. All right, so let's do these things. First unit 1 test is all algebra 1 stuff. So plus 10, you're going to have 6x equals 96 divided by 6 divided by 6, x equals 16. I'm going to go a little fast for these simply because you could rewind and go back. And the reason is also this is algebra 1 stuff, so I don't want to spend too much time explaining this. Minus 3, x over 2 equals 4, times 2, because it's x divided by 2, x equals 8. All right. Next one, it's 5, 2x, so we're going to distribute. So that is 5x plus 10, remember to distribute the 5 to the 2, equals 100, minus 10, 5x equals 90, divided by 5, x equals 18. 3, so let's distribute the 3 to both 3x and 1. So that's 9x plus 3 minus 5 equals 70. Now on the left side of the equal sign, so the left side of the equal sign over here, we have two numbers that are like terms. So 3 minus 5, we could do that as negative 2 equals 70. Plus 2, 9x equals 72, divided by 9, x equals 8. Over here, we're going to have, now we have x and negative 4x. We could combine like terms because they're on the same side of the equal sign. So 1x minus 4x is negative 3x minus 4 equals 17. And let me just zoom this a little bit in. Plus 4, negative 3x equals, plus 4 is 21. Divided by negative 3 is a positive divided by a negative, so your final answer should be negative 7. Not positive 7, but negative 7. Next one, x plus x, so that's 1x plus 1x, and I'm going to distribute this also. So I have 2x minus 4 equals 2x minus 4. At this exact point, you can see they're exactly the same. Let's say you're doing the work and you don't notice. So let's just keep going. Minus 2x. So we got negative 4 equals negative 4. At this point, notice that the x is completely canceled out. So at this point also, you could have noticed it up here and you could stop right here and write the answer. But over here, it's negative 4 equals negative 4. Negative 4 equaling negative 4, what does that mean? Well, that is a true statement. And since that's a true statement, your answer is all real numbers. So it'll look like a symbol like this, or I write out the words all real numbers, okay? Here, take 4, distribute it here. So we got 8x minus 4 equals 5x minus 5. Minus 5x. So typically some people like to move the numbers without variables. I like to move the variable first, and I like to move the smaller variable first. So I'm going to move negative 5x. It helps avoid negatives, which I know not a lot of people love to see. So this is 3x minus 4 equals negative 5 plus 4. That is 3x equals negative 1. And then divided by 3, x equals negative 1 over 3. Okay, and it's okay if it's a fraction. You guys can deal with fractions. It's not the biggest thing in the world. Over here, we're going to take the 3 and distribute to both 4 and 2x. So we got 12 plus 6x equals 12 plus 6x. Just like I said before, they're exactly the same. That's all real numbers. I just want to show example, and because I don't think on the test it shows an example of a no solution. So, and I'll do it underneath, or I'll do it right here. So let's say if it was something like 3x plus 1 equals 3x plus 2, and you subtract 3x on both sides, and you notice it's 1 equals 2. As soon as you see that's not a true statement, then we could say that's no solution. So it usually looks like a 0 that's crossed out with a 0, or a 0 that's crossed out like that, or I'll write the words no solution. Next one, 3 times x, 3 times negative 2. We got to distribute that. 2 times 2, 2 times 2x, 2 times 1. So that's 3x minus 6 minus x equals 4x plus 1. The x's are on the same side, so 3x minus 1x is 2x minus 6 equals 4x plus 1. Like I said earlier, I like moving the smaller x over, so minus 2x minus 2x. And I'm going to also at the same time move the 1 over, because now I'm going to have the 1 here, minus 1 minus 1. So I have 2x equals negative 7 divided by 2 divided by 2. Negative 7 over 2 equals x. As a decimal, if you put that in your calculator, negative 3.5 equals x. Okay? All right, writing expressions is word problems. When you see expressions, there's going to be no equal sign. Here's the hint. If it's equations, then you know you're going to have an equal sign. But if there's no expressions, then it's not going to be equal sign, okay? This should be... So let's continue. Number 10, the sum of 3 consecutive even numbers. So I'm just going to write 2 sets of even numbers. 2, 4, 6 is the first set everyone thinks of, and maybe 10, 12, 14. So how do I write that as a variable? And then as a variable that doesn't have anything watching. So we're going to do x plus, so the first number is x, so the lowest number is x. The second number, every even number is 2 away from each other. So you're going to write the next one as x plus 2. And then the next even number is 2 plus 2 away from each other, so x plus 4. I could combine all the like terms, and then becomes 3x plus 6. If it was a multiple choice, I probably would write 3x plus 6. If it was an open-ended question, you could write either one, and I'll take the answer. Let's continue. Next one, we have the length of a rectangle is 5 more than the width. If the width is x, what is its area? Okay, so we know 2 things. One, the length is 5 more than the width. So length is whatever your width is plus 5. Let's set this like this. There you go. Okay. We also know the area of a rectangle. The area equals length times width. So now this L right here, length, could be substituted with this L right here. So that is going to become A equals W plus 5 times W. I could distribute the W both ways. So your area equals 2W plus 5, W squared plus 5W, okay? Let's go to the next one. The sum of twice a number and the cube of the same number. So sum tells you plus, so plus something. Twice a number, twice is 2 times a number. I use x as my number. You could use any letter, honestly. And the cube of the same number. So any number cubed is x to the 3rd power. Okay? Next one, 4 more than a quotient of a number and 11. So 4 more, so 4 plus. The 4 more than quotient. Quotient means divide. So 4 plus the division of a number, so that's x, and 11. So that's 11. So 4 more than the quotient of x and 11. You could also write it like this. If it was an open-ended question, it would look like this. But if it was a multiple choice question, I would write the top one. How do you solve, so Hani asked a question, how do you solve for length when you only have variables for the perimeter area like we had on the review test? I think that's on the upcoming question, number 15. So when I get there, you'll see, okay? And then if you have a question, just ask right after. Let's continue. Let's do this one, and then we'll get to 15. 10 less than a 3 times a number. This one's really important to think about. 10 less than 3 times a number is the same thing as saying 3 times a number minus 10. You cannot do it the other way, okay? You cannot do it the other way. Because think of it if I said it with normal numbers. 10 less than 100. Well, 10 less than 100 would be 90, which is 100 minus 10. So 10 less than 3 times a number is 3x minus 10. So, honey, this should answer your question. What happens if we have length, but we only have the variables for perimeter and area, like this one over here? So, number 15, the rectangle has a perimeter of 60. So we know P equals 60. And I'm just going to draw a box to represent a rectangle. So length, length, width, width. The length is twice the width. So we have another relationship we know, which is that the length, L, is whatever the width is times 2. So twice the width is 2 times the width. What are its dimensions? So the dimensions between, so when we say dimensions, we mean what is the length and the width. And you look at this information, you're like, well, there's not enough information to do anything. Like this is P equals 60 and this. But we do know one thing. We know the perimeter is supposed to be all the sides add up. So the perimeter is your length plus your width plus your width. So those things added up should equal something. Now, should equal the perimeter, I should say. We know the length over here. We have 2 L's over here. And we can replace those L, or what we call substitute those L's, with the 2 W's. So now we only have one variable each. So the perimeter, and actually I could do this at the same time, this P up here, we could substitute this P up here with an actual number we know, which is 60. So 60 equals 2W plus 2W plus W plus W. All those W's could be combined into one set, like term. So that's 6W divided by 6 divided by 6. 10 equals W. Now, if the width is 10, and that's one of our answers, if the width is 10, what can we do about the length? Well, just from the original problem, we know the length is twice the width. So we could just do 2 times 10. So the length is going to be 20. So length equals 20. And you could plug it back into this equation. And this kind of leads up to our system of equations on the next chapter, or whatever chapter that was. Number 16, 8 more than 3 times the number is 83. So 8 more, that's plus, than 3 times, so 3 times, a number, some variable, is equal, no problem, is equal 83. What is the number? Okay, so now we just solve like a normal algebra problem. Minus 8 on both sides. 3x equals 75. Divided by 3, x equals 25. Pretty straightforward. Let's go to the next one. Joe has $14 more than David. Together they have $72. How much does each have? So there's 2 ways to solve this question. And the 2 ways to solve this question is, let me just fix something here on my phone, is to set, let's do the first way. So one relationship I know is that Joe, whatever David has, Joe has $14 more. So I could write Joe equals David plus 14. And I also know whatever Joe has plus whatever David has added together is 72. So how do I do this? Well, again, a little substitution is happening. Joe could be replaced with D plus 14. So D plus 14 plus D equals 72. 2D plus 14 equals 72. Minus 14 minus 14, 2D equals, this is going to be 58 divided by 2, divided by 2, D equals not 60, but 29, okay? So David's money is 29 bucks. So then from there, we're going to take David's money and plug it into one of our equations here. Kind of like a system of equations. You notice this is a relationship. But we do this problem-solving style, which is like try to think about how do we set them up. Well, system equations, we set it up exactly in a certain way. So 29, so we do who's it, Joe? Joe is $29 of David plus 14 more. So Joe should have $43. I apologize. And then we could just check real quick. 43 plus 29 is definitely 72. So it makes sense. They have that. And then Joe definitely has 14 more bucks than David in that case. All right, we're almost done with chapter 1. This two planes question literally tricks up a lot of people, but it's actually very straightforward. So you have two planes, one flying east and west. So notice that's this complete opposite direction. So east is 340 miles per hour, and west flies 220 miles per hour. And I should say, I guess I have to make sure in the question I say they're leaving from the same place. We're trying to figure out how long does it take them to be 1680 miles away from each other. Let's first figure out how much they get away from each other in 1 hour. So 220 plus 340 added together, because they're going separate directions, right? So they're getting farther from each other. It's not like one's chasing the other guy. So each hour, they're getting 560 miles away from each other. And we know our goal is to get to 1680. So what we want to do is do 1680 divided by how many hours it takes. So 560. So 1680 divided by 560, you type in your calculator, that's end up going to be 3 hours. So it just really is figure out how far away they get per hour, and then just divide how much per hour versus your goal. So it'll take them 3 hours to be this far away from each other. All right, last one, an easy one. 2 times, so times is multiplication, 2 times a number, that's x, plus, I literally just wrote plus, 8 times a number, I should say it's the same number, equals 210. What is the number? So is, by the way, is equal, okay? And let me just zoom in because it seems to be a little fading out a little bit to me at least. Okay. So 2x plus 8x is end up going to be 10x equals 210. Divided by 10, divided by 10, that number is 21. And you could plug it in and check it out, but trust me, it's 21. So that's the unit 1. So why don't we go to unit 2? All right, plot the points, find the quadrants. Now, just to remind you, the quadrants, this is quadrant 1, 2, 3, 4. Just like that. Wait, let me just actually make sure it's quadrant 1, 2, 3, 4. Because somebody corrected me the other day. Quadrants of a XY grid. Quadrant 1. Oh, I'm sorry, the wrong direction I went. So it should be 1, 2, 3, 4, like that. So it's counterclockwise, okay? 1, 2, 3, 4, like that. All right. So first it says point the plot. So why don't we plot the graphs, plot the points. A is 1/4, so I'm going to go here. 1, 4, it means I'm going to go 1 right, And 1, 2, 3, 4 up. That's A for me, okay? A little A right there, all right? B is going to be 0, comma, -2. So 0x means I'm not going left nor right any points. And then -2 is 1, 2 down. So that's B. C is 4, comma, 0. So 4 is 1, 2, 3, 4 to the right. 0 up or down. So that's that. D is -2, comma, 1. 1, 2 to the left, because -2x is 2 to the left. And 1 up. So 1 up is right here. So this should be D. And then E is -3 to the left. 1, 2, 3. And -4 down. 1, 2, 3, 4, like that. And that's E. Okay? And then I said what quadrant or axis is on. So 1, comma, 4 is over here. That is the quadrant 1. Doesn't have to be the Roman numeral. You could just write the number 1. 0, comma, -2. So that is not on a quadrant. It's between 3 and 4. It's between 3 and 4. So that is on the y-axis. So you're going to say the y-axis, okay? And I realize it's on the camera. Y-axis. All right. Next one, 4, comma, 0. That's on the x-axis, so we write x-axis. -2, comma, 1. 2 left, 1 up was here in D. That's quadrant 2. And -3, comma, -4 is down left, so that's quadrant 3. All right, let's go into the next one. Find the slope between 2 points. x1, y1, x2, y2. So the formula for the slope is y1 minus y2 over x1 minus x2. And it's very important to know whether you put y1 or x1 in front or in back, it doesn't matter. It's the same thing. So let's continue. So I already labeled this. I labeled it ahead of time. So -8 minus 1 over 2 minus 4. Now, like I said, it doesn't matter if this is y2 and y1, or you call this group 2 and you call this group 1. What matters, though, is you're consistent. So if -8 is in the front, you should put 2 in the front. That's the only important part that's because you need to be consistent in. So -8 minus 1 is -9 over 2. 2 minus 4 is -2, I apologize. A double negative will become positive 9 over 2. Since we're talking about slope, we'd rather have it as a fraction because when we graph, we want to go up a certain number and go right a certain number. Let's do another one. -4 and 6, so this is x1, y1, x2, y2. So -6 minus -6 over, what did I say, y1 first? So -4 minus 9. Now over here, we got double negatives, so that's plus. So that's -6 plus 6, that's 0 over -13. Now, when the top of your slope is 0, it doesn't matter what's on the bottom, unless it's also 0. In that case, it is a 0 slope. Okay? So it is a 0 slope. So it would be like a flat line like that. Next one. What is the slope for this equation? So this is a y equals mx plus b. I'm not telling you y equals mx plus b. Like, I'm not explicitly telling you it's that. But you should know, because notice the y is by itself. And that's the only equation version where the y is by itself. So y equals mx plus b. M stands for slope. So the slope here, if m, where m is a 7, that would apply the slope is 7. Well, b is the number not near the x. So if b is -6 here, then -6 should be your y-intercept. This is m, and this is b. Let's go to the next one, number 5. Y minus 3 equals 6, parentheses x plus 1. What's the slope? Now this one, when it's y minus something, and not x, I should say, you should notice that is point slope form. That's y minus y1 equals m x minus x1. So let's see where m stands in this case. M over here is 6. So that's very easy. It's just 6. It's this number right here. The y-intercept, though, notice there's no b in the original equation for this type. So because there's no b for that type, what we're going to do is get rid of y-intercept by doing what we do for the quadratics. So what we did in chapter 1.1 to 1.4 is to plug in x equals 0, okay? When x equals 0, that's where the y-intercept is. And I'm going to plug it into this equation right here. So y minus 3 equals 6. 0 becomes the x plus 1. I could do inside the parentheses first. So y minus 3 equals 6 times 1. 6 times 1 is obviously 6. Y minus 3 equals 6 plus 3 plus 3. In this case, y is 9. So your y-intercept is 0, 9. If you just wrote 9, that's okay too. All right? Next one. Write an equation for each line where, given the information, it could be in any form. All right? Well, look at this. We have a slope of -5 and a y-intercept of +7. So to use slope and intercept, we're going to use the slope-intercept form. The slope-intercept form looks like this. Y equals mx plus b. So y equals mx plus b. So if the slope is -5 and the y-intercept is 7, we're just going to plug in what we know. Slope is 5. So this is -5x. I'm sorry, slope is -5, so -5x. And y-intercept is 7 plus 7. At that point, you're done. That's one of our 3 forms, and we're happy with that. All right. The slope of 2 is passing through 3, 5. So the slope of 2 is 3, 5. Okay? So this one, we have a slope and we have a point. While we have a slope and a point, we're going to use point-slope form. I'm also going to show you how to do a y equals mx plus b form, because I know a lot of people prefer that version. So first, let's put it in point-slope form. So for this one, we could simply do y minus whatever our y1 is here, so our actual y point, so 5, equals our slope, m, 2, x minus x1, which is over here, 3. Oh, and if you didn't remember what the equation was from the last question, y minus y1 equals m, x minus x1. Okay? So that would be a completely applicable answer. But some people don't like that, or some people prefer y equals mx plus b. So let's say if I told you very specifically to get y equals mx plus b, which is a slope-intercept form. Well, I have a slope, and I have a point. What I'm missing is this guy over here, which is b. So what I'm going to have to do is take this 5, plug it in for y. Take this slope, which is 2, plug it in for 2. Plug this 3 in for x, plus b, and do my algebra in order to solve for b. 5 equals 2 times 3 is 6 plus b. Minus 6, minus 6. -1 equals b. We're not done at that point. Even though we found b, we have to set it up as an equation. And our equations always have y as x as a variable, because the purpose of the equation is to use it to find something else. So y equals, this is 2, the slope is 2, x. Now we figured out what the b is, which is -1, so we could write -1 there. So both answers are applicable. I would like you to know both answers, but probably this one's a lot easier when you know what you're doing. Let's go to the next one. So 2 points that are passing through these, a line that's passing through these 2 points. So typically when we deal with these things, we have slope. So when we have slope, that usually makes it easier. But we don't have slope, so what we could do is find slope. So let's find some slope. So I'm going to set it up again, y1 minus y2 over x1 minus x2. So that's going to be x1, y1, x2, y2. Give me a sec. Oh, here you go. So that is going to be 4 minus negative 1 over 5 minus 6. So that is going to be 4 minus negative 1. So minus and negative is plus. So that's 5 over negative 1. And even if the negative is just on the bottom, a positive divided by a negative is a negative. So that is going to be the negative 5. So our slope is negative 5, okay? But we're not done with that. So then we have to go and plug it into either form. So before, we could put it in point-slope form. And now we have a point and a slope. We could just simply do y minus 4 equals negative 5 x minus 5. It would also be the correct answer if you use negative 1 here, and I'll just write it here. So negative minus negative 1 would be a plus 1 equals negative 5 x x let's see. I'm looking for a pen. Okay, it seems to be working now. All right. X, I got to be a little bit nicer to it. X minus 6, okay? So those are both the same answer, but I'll just show you how to do it with the y equals mx with b like I did here. Y equals mx plus b. Notice we already found m, so we could just choose either one. I'm going to choose this one just to be slightly different. Negative 1 equals, and you'll get the same answer regardless if you chose the right point or the left point. So 1 equals negative 5 times 6 plus b. Negative 30 plus b equals negative 1 plus 30 plus 30. 29 equals b. But we're not done. We got to set it up as an equation. Y equals negative 5x plus 29. Okay, so either this answer or these two answers are perfectly fine. Ooh, we're going to graphing. So some people's dreaded situation, okay? All right, so graphing. For some reason the thing is getting unfocused. Hopefully it hasn't been like that for a while. So graph a line given this stuff, okay? And let me just change the camera a little bit, so zoom in. So graph this equation, okay? Okay, so graph this equation. So we have y equals 3x plus 6. So this is in y equals mx plus v form. And what that's really useful is we already get basically a free point and the slope. So the slope is the number in front of x, which is 3 over 1. And you'll see why I put 3 over 1 later. And for b, which is our y-intercept, is 6. So remember, the y-intercept is where x equals 0. So this means that this point is 0, 6. So I'm going to go where 0, 6 is, which is 1, 2, 3, 4, 5, 6 up from the origin, and put a point here. Now, 3 over 1 is the slope, and I'll just write it on the right. 3 over 1 is the slope, and remember slope is rise. You have to rise above the running. So you have to rise 3 and run 1. So up 1, 2, 3, and right 1. Let's say if you didn't have space up there to grow, so you could do the opposite direction. If you go down 3 and left 1, that's the same thing. Think about it, because you're going backwards. 1, 2, 3, and 1 left. Because backwards, so you could go up the same way. 1, 2, 3 up and right 1, and it would work out. You only need 2 points for a line on the test, so 2 was enough. I just want to show you the backwards way. You connect your dots as best as possible. Literally, I don't care about how straight your line is. I care about where these points are more than anything. Let's go to the next one. Now we have a point slope form. And if you don't remember, that's y minus y1 equals m, x minus x1. Now, a lot of people try to turn it into y equals mx plus b, and I think that's the wrong move you should do. I think you should leave it like this and use what we know. So we know m is the number in front of the parentheses. So we know m, and thankfully, sorry, fraction for us is 2 over 3. Now, let's find x and y. We have a particular x point and y point shown here. So x minus x1. Now let's think about it a little bit. Let's think about it. The original question is minus. So for this to be a plus sign right here, this had to be a -1. This had to be a -1, or it would be just x minus 1 if it was a positive 1. So our first point is -1 for our x. And our y is y minus 5, so that must be y minus positive 5. And the other way you could think about it is because the equation says minus, you have to flip the sign. So it was -5 here, it's going to be positive 5 on the point. So we have -1 comma 5. What that means, we're going to go left 1 and up 1, 2, 3, 4, 5. Okay. And if we go up 1, 2, 3, 4, 5, just like that, we can now take the slope, which is still rise over run, that never changes. So go up 2, 1, 2, 3 to the right. Just pretend if we went reverse, that'd be 2 down, 1, 2, 3 to the left. Again, you only need 2 points. I'm just showing 3 because it's helpful to know both ways. Again, I don't really care about how straight your line is. I care about where those points are. Last one, I think, for chapter or unit 2. This is a standard form 1. Now, what's the benefit of standard form 1? You could change it into y equals mx plus b. And if you do, and I'm just going to do that quickly for you, but I want to show you a different way to graph this. But if you were to do it, it would end up being, because some people might have done that, 3 over 2x, negative 3 over 2x, plus 3. Okay? Let's say you could have done it like that. And if you want to do it like that, that's perfectly fine. I just wanted to write that so people could check their work if they did it this way. What I'm going to do is use the x-intercepts and the y-intercepts. Now, this technically works for every type of problem. What's beneficial here is because it's just 6 times x, at the x-intercept. Now, remember, actually, let's do y-intercept first. The y-intercept is where the x is 0, and it's some number. So why don't I plug that in first? So this is the y-intercept section, okay? So that is going to be 6 times, oh boy, 6 times 0. 6 times 0 plus 4y equals 12. Cancel that out. It's just 4y equals 12. So that is divided by 4, y equals 3. So the y-intercept is 3, and I could just graph that. Go 1, 2, 3 up. And hey, we kind of actually knew that from the point slope form. Look at that. So that matches. That's pretty nice to see. But what about the x-intercept? So if the y-intercept is when x equals 0, what is the x-intercept? Well, that's when the y equals 0. So x over here is going to be 6x plus 4 times 0 equals 12. Well, 4 times 0 disappears. So 6x equals 12 divided by 6 divided by 6. X equals 4. I'm sorry, I'm really dumb. X equals 2. So x equals 2. So x equals a positive 2. So we're going to graph positive 2 comma 0. So starting from the origin, 1, 2 to the right, 2 to the right, and then we're going to draw a line connecting it. This is the best line I drew yet, but you could connect the 2 dots like that. Again, you could also turn it to y equals of x plus b. I don't want to focus on it because I think this method is better for that situation, but to each their own. Whew. Now for the system equation ones, I'm going to skip around because a lot of these are repetitive. I just want to show all the different types. So this one right here might be best for a simple elimination. And the reason we could do elimination is because this is a positive 3y, this is a negative 3y. So we could make a big plus sign here. And remember, in this goal is to find both x and y. So we want to find both x and y. So a big plus sign here, 2x minus x. So we're going to subtract, or add down. So 2x minus x is going to be just x. 3y plus negative 3y is end up going to be 0y. And it's really important. One of our letters should become a 0, and I'll show you why. Negative 12 plus 18 equals 6. So this one, 0y, is going to get canceled out. So I'm left with x equals 6. Now I'm going to take this x equals 6. Let me box it out. And I'm going to take it, move it up here, and plug it into one of these equations. I'm going to choose the top one, but if you chose the bottom one, you will also be totally correct. So let's plug it in. 2 times 6, and I plug it in for x because I found x. So 2 times 6 plus 3y equals negative 12. This is 12 plus 3y equals negative 12, minus 12, minus 12, 3y, negative 12 minus 12, so that's deeper down in the world, so that's negative 24, divided by 3, divided by 3. Y equals negative 8. Now sometimes you would like to check your answers, or maybe if it's a multiple choice, you want to try each A, B, C, D, like all the options. So you just take 6 and negative 8 and plug it in here to either equation. You should actually, if you want to check it fully, you should check it to both equations. I'm only going to do this for this one, but typically this is how you do it. 6 times 2 is 12. 3 times 8 is negative 24. 12 minus 24 is negative 12. Negative 6 minus 3 times negative 8. So negative 8 times 3 is going to be 8, 16, 24. This is going to be a positive 24 though. So negative 6 plus 24 is definitely 18. So you could plug into both of them, and if you are going to check like that, you need to plug into both of them. All right, number two is a simple one because look at this. It's just 2y equals 12. You know what's really nice? On the bottom, don't look at the top yet, but on the bottom, I could just divide 2. Hey, y equals 6. I just got one of my answers early. Oh, and before I go on, the answer would be shown as 6 comma negative 8 because it's the xy coordinate. So y equals 6. Wow, that was super easy. So what I'm going to do, I can plug it back in here, but that doesn't prove anything for x. So I'm forced to plug it into the other equation, okay? So negative 7x plus 8 times 6 equals 13. Negative 7x plus, this is 48, equals 13, minus 48, negative 7x equals negative 35, divided by negative 7, divided by negative 7. I wrote 5 there because I got too ahead of myself. X equals 5. So your final answer should be 5, comma 6. Next one. All right, we kind of see an elimination going on, but there's a big issue. This is negative, this is negative. So I learned that the best way is not to say subtraction. Let's multiply everything here with negative 1 and then rewrite it. So I'm going to rewrite this one right next to it. So 2x minus y equals 17. And I'm going to rewrite this one with a negative to distribute to everything. And it turns out a lot of people like this way better than just subtracting. So I'm just going to keep to it. Minus x, negative 1 times negative y is going to be a positive y, equals negative 10. And then so from there, we're going to solve it out. And we're going to do a big plus sign and then go down. So 2 minus 1 is x. Negative 1 plus 1 is 0. So I'm not even going to, well, I could write it. So 0y. But that's going to get crossed out. equals 10 plus negative 10 is 7. So x equals 7. That's really nice. Take that x equals 7 and plug it into one of the equations. I'm going to plug it into the bottom one. And you want to plug it into the original one. You could technically plug it into the new version, but the original one is usually the better one. So 7 minus y equals 10, minus 7 minus 7. Negative y equals 3, but we have to divide by negative 1 to get the y by itself. So it's y equals negative 3. So your final answer is 7 comma negative 3. All right. Like I said, I'm going to skip some if I think it's too redundant. So like number 4, you're just going to subtract down. You'll get, actually, I'll do this one. No, I won't. Yeah, I'll do. So this one, let's do the bottom. Let's multiply it again with negative 1. You could multiply the top by negative 1, by the way. It doesn't matter. So x plus 4y equals negative 3. And this is going to be multiplied by negative 1. Negative 1 x, I didn't have to write the negative 1, minus 7y equals positive 12. All right, let's vertically add. 0 minus 3y equals 9. Now, usually the last two problems, and the reason I did this one is because the last two problems, they didn't have anything next to the x or the y. So I'm just going to divide negative 3, because this disappears completely. So I'm going to divide negative 3 on both sides. So y equals negative 3 for me, because 9 divided by negative 3 is negative 3. So take that, plug into one of my original equations. I'll plug it into the top one because it has smaller numbers. And let me just make sure this is on the camera. So then over here, it's x plus 4 times negative 3 equals negative 3. X plus negative 12, or I could say, right, x minus 12 equals negative 3. Plus 12, plus 12. X equals 9. Okay, so your final answer is 9 comma negative 3. And when we're going for 46 minutes already. This one over here. Okay, so this one I'm going to use a substitution method. Now, why would I use a substitution method? Well, this doesn't line up numbers, this doesn't line up numbers, and I have a y by itself. So what I could do on this bottom one only, I would be doing this, is I'm going to subtract 5x on both sides. What does that allow me to do? So it becomes y equals negative 5x plus 22. You could write 22 minus 5x. Now, if I have a y here, just like we did in Unit 1, you could substitute that y for something else over here. So what I'm going to do is on the top part, I'm going to do 7x minus 4 parenthesis negative 5x plus 22 equals negative 7. So I'm going to take this negative 4 and distribute it here and here. So 7x, negative 4 times negative 5 is positive 20x. Negative 4 times negative 22 is going to be negative 88 equals negative 7. Now we're going to solve large numbers, but a algebra 1 problem. Plus 88, and then I could combine like terms. So 27x equals, this is 81. Divided by 27, divided by 27. You all should bring calculators to the test, but x equals 3. Now that x equals 3, I can plug it into either original and solve it. Typically, the best move is to plug it into the different original, but it doesn't matter. 5 times 3 plus y equals 22. This one's a lot better too because there's nothing next to y. 15 plus y equals 22. Minus 15 minus 15. Y equals 7. So y equals 7 for that question, okay? This one, you could do a substitution. I'm just going to keep going. I feel like I've done a bunch of eliminations and substitutions. And I kind of want to make sure I get to the word problems. Let me see. 7. You divide 4 on both sides. So you get y equals 5. You could take that and plug it into here. 7x plus 3 times 5 equals 22. I'm going to cut the math quickly and get you x equals 1. So 1 comma 5. Let me do number 10, though. Number 10, no, number 10 is a straight elimination. Yeah, there's something I really want to do out of these. So I want to move on to the word problems to make sure we get that. Okay, so first let's talk about the word problems. The word problems are, yeah, they're tough because they're word problems, but they're very doable. And once you set it up, it's just like doing the other problems that we did on the previous page, which, if I remember on this test, a lot of people did well in. So you definitely could do at least the first page stuff, or the first 3-page stuff. Okay. The school that Stefan goes to is selling tickets to a caroling performance. So that sentence is completely worthless. If you want to cross it out, that's fine. Who cares about Stefan? On the first day, the ticket sales of the school sold 3 senior citizens tickets and 1 child ticket for $38. That's a very important sentence. So on the first day, we could write that 3 senior citizens, so I'm going to put S for that, plus the 1 child ticket netted them the cost of $38, or they earned $38, I should say. So like if 3 grandpas and their grandkid came, that would be $38 for that price. Over here, the school took on $52, so we know $52. On the second day, by selling 3 senior tickets, again, maybe this is 3 grandmas, plus 2 children, so maybe 2 grandchildren, and that cost them $52 in total. Well, when you set up these 2 sentences like that, wait a second, this looks like this, and this looks like that. Hey, we got ourselves a nice, clean elimination. What I'm going to do is times everything by -1. And then let me just rewrite everything. So 3s plus 1c equals 38. And -3s plus minus 2c equals -52. Sometimes you might want to look at the other numbers, and if this is smaller numbers, it might be better to make those negatives. Okay, so let's go on. 3s minus 3s is 0. 1 plus -2 is going to be -1c. And 38 minus 52 is going to be -14. Divided by -1 on both sides. Because it's not like -14 would imply that the ticket paid you $14. So it can't be -14. So think about it in the real sense. So that has to be $14 for the child's ticket. Well, now if I know it's $14 for the child ticket, I could plug it into one of these original equations. So I just want to make sure it's on camera. So 3s plus 1 times 14 equals 38. 3s plus 14 equals 38. Minus 14, minus 14. 3s equals 24. Divided by 3, divided by 3. S equals 8. So S equals 8. So that's the senior citizen tickets. They're paying a lot less than their children. So that's very nice for them. Nice for the old people out there. All right, let's go to the next one. Pizza at Tony's is $12 a pie. So I'm going to say it's $12 plus, and I'll just do the whole number 12, 65 cents, so 0.65 for each topping. So I'm going to use T for topping, okay? The next place, Frank's, is $10.50 plus 1.15 per topping. And I just went through fast like that, so let me actually slow down for a second. So when you order a pizza pie, you're only on 1 pie, and then you're going to order some amount of toppings. You don't know how many toppings. So we're going to leave toppings as the variable T for here. The same at Frank's. You're going to order 1 pie, which is $10.50. And each topping, we don't know how many toppings we're going to order, is 1.15. What amount of toppings of the pizza is the same price? So same is the key word here. When you have them same, you're going to do 12 plus 0.65t equals, and we're going to set them equal to each other because they're the same. We want them to see when they're the same price. Equals 10.50 plus 1.15t. So let's do some math. I'm going to do it quickly. Minus 10.5, minus 10.5. Again, I like moving the smaller t over, so the t 0.65 here. That's a minus. Minus 0.65t. So that's going to be $1.50 equals, I don't need to actually write the zero, but I just do because we're talking about money. Over here, it's going to be 50 cents for every topping. So what this actually represents is that every topping, they get closer 50 cents, the price. So divided by 0.50, divided by 0.50, T, which is the amount of toppings, is 3. So at 3 toppings, both at Frank's and Tony's is the same price. So if you want to think about it more, at Frank's, it costs 1.15 per topping, right? So after you got 3 toppings, and let's say you're going for 4 toppings, maybe it's better to go to Tony's because it's a bit cheaper. That's, of course, not thinking about the actual pizza itself. But in price-wise, it's better. All right. This is the same type as the previous question, okay? So this one over here. This year, the senior citizens Class A and Class B went to a trip. Class A rented and filled 8 fans. And there should be some amount of buses. And 8 buses. So 8 vans. And the van, V stands for how many people are in the van. And 8 buses, and it says for how many people are in the bus, for 240 people. School B rented 4 vans plus 1 bus equals 54 students. And the reason I skipped these previous type of problems is because I knew I was going to do them here. Notice how we're really close. We could do a substitution. I want to show another method, which is multiplying by a factor and still doing elimination. So 8 and 4 is really close. Like I just need to double 4 and it will match 8. So I'm going to multiply the bottom by -2. Now, I just want to talk about this. If you did substitution, which you minus 4v and then substitute, that's fine. But I'm just doing this to show a different way. So I'm going to multiply this whole thing by -2 and make sure to distribute to everyone here. So I'm just going to rewrite 8v plus 8b equals 240. And over here, I got -8v minus 2b equals -108. Let me add straight down. So -8 plus 8 is 0. 8 minus 2 is is 6, just positive 6b. And 240 minus 108 is 132. So 6b equals 132 divided by 6 divided by 6. B equals 22. So what does that imply? The bus can hold 22 people. The bus can hold 22 people. Now, since I know the bus could hold 22 people, I can figure out how many the vans hold. So I'm going to plug it into the bottom one here. So 4v plus 1 times 22, don't really have to write the 1, equals 54. Minus 22, minus 22, 1 times 22 is 22, so I'm just going quick. 4v equals 32 divided by 4 divided by 4. V equals 8. So V equals 8. Bus equals 22. So the bus could hold 22 people while the van holds 8 people. Last one of the word problems. Billy is selling clothes. On day 1, he threw 3 shirts plus the 5 pants for $55. The next day, he sold 5 shirts and 5 pants for $65. Okay, let's fix this up a little bit. All right, and then hopefully it doesn't fall again. Oh, if I do it like this, it won't fall. Don't go crazy. Okay, now it's working for now. All right, so 5s for 5p equals 65. Just to set up from the sentences, 3p for 5s equals 55, 3s for 5p is 65. Subtract down, or you can multiply everything by 1. I'm just going to go quick and subtract. 3 minus 5 is -2s. 5 minus 5 is 0. Equals 55 minus 65 is -10. Negative 2s equals negative 10. S equals 5. So 5 is per shirt. So the shirts cost $5 each. Plug it into the one with the smaller number. So 3 times 5 equals 5. Oh, plus 5p equals 55. Shouldn't have made S's because my S's look a lot like 5. So I should have used shirts and 5s a lot. 15 plus 5p equals 55, minus 15 on both sides. 5p equals 40. Divided by p on both sides, p equals 8. So the pants were $8, the shirts were $5. Oh man, we're almost there, and we're only an hour in. Oh, almost exactly an hour in. I was a little late for that. All right, 1.1 and 1.4. This, let's say, stumped a lot of people, but it's not that bad. They're not that bad. Okay, y equals x squared plus 4x minus 1. What are we going to do about that? Well, I could find the x of the vertex. And to find the x of the vertex when it's in this form, which is standard form, it is negative b over 2a. And what is a, b, c? Just remember, a is the first number, b is the second number, c is the third number when it's descending like this. So negative... Okay, so negative 4 over, because this is a 4, 2 times 1, because there's no number in front of x squared, so it's 1. So that's negative 4 plus, let me just try to hide, something went on my phone, it's kind of hard to see. Whatever. Okay, don't fall again though, buddy. All right. So negative 4 over 2, which is negative 2. So your x of your vertex is negative 2. So the x of your vertex is negative 2. So what we're going to do is take this negative 2 and plug it into this equation here. Negative 2 squared. And if you're using a calculator, make sure to put in the calculator parentheses, because if you write negative 2 squared, it's going to give you negative 4. But it should be negative 2 being squared. Negative 2 times negative 2 is a positive 4. Plus 4 times negative 2 plus minus 1. Okay. Negative 2 squared is negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. Plus 1, or no, sorry, minus 1. I feel like I did that twice in a row. 4 minus 8 is negative 4 minus 1. That's negative 5. So your first point is negative 2 comma negative 5. You know what's really nice? You know what's really, really nice? The axis of symmetry is simply the x of the vertex. So the axis of symmetry is negative 2. The min-max value is simply the y of the vertex, which is negative 5. What is it if it is a min-max value? Is dependent on a. A is a positive number. So A is a positive, it goes up. Think of a positive person, happy. Negative person, they're sad. It goes down, okay? So happy person, that means here is the lowest point it goes, which is the minimum. So since it's a positive version, it is the minimum. The y-intercept. Now the y-intercept is very good about this. You could plug in x equals 0. But this equation, what's really nice, is if you plug x equals 0 here, this disappears. If you plug in x equals 0 here, this disappears. So you're just left with negative 1. So my y-intercept is 0 comma negative 1. In the standard form, it's always just c. Okay? Last one, give me 2 other points. So how do you get 2 other points? Well, the easiest way to get 2 other points is you take the x of your vertex and use 2 numbers that are next to the vertex. So that's negative 1, and that's negative 3. So let's see if those numbers are going to end up being the same when I plug it into the original equation, which is up here. So negative 1 squared plus 4 times negative 1 minus 1. That's 1 minus 4 minus 1. So that should be negative 4. Let's check the next one. Negative 3 squared minus 4 times negative 3 minus 1. Sorry. 9 plus 12 minus 1. Oh my god, it's negative. Have I been messing this up the whole time? No, it's plus 4. So it's minus 4. Yeah, right. So it's minus 4 here, but this is plus 4. So then this should be minus 12. Okay. So 9 minus 12 is negative 3. Negative 3 minus 1 is negative 4. Then we're going to simply graph those 2 points. Actually, let me just write here. Negative 1 comma negative 4 and negative 3 comma negative 4. You know you did it right if both the y's are the same value. Let's graph all those points. 2 comma negative 5. 1, 2, 3, 4, 5. 1 comma, oh, this is negative 2. I'm sorry. So negative 2 is 2 to the left, 5 down. 1, 2, 3, 4, 5. And then 1 to the left, 1 to the right. Make a U shape. Again, he's happy because we know it's a positive A. Let's go to the next one. Come on, buddy. Let's go to the next one over here. Graph these suckers. Okay, vertex form. You know what's really nice about vertex form? It's HK, but it's the reverse, so you got to make sure you get the positive. So it's actually positive 3 comma 5. You got to flip the H on this one. So the axis of symmetry is positive 3. The y max value is 5. A in this case is negative 2. So that's a sad guy. Sad guy has the top of his mouth. So that is going to be a minimum, or a max 0. So we actually have to plug in 0 for this one. The other one was straight quick. You just plug in 0, 2 of the things disappeared is left over. So this one, we're going to plug in 0. So negative 2, 0 plus, what is it? Minus 3. Minus 3 squared plus 5. Negative 2, I just combined with negative 18 plus 5, negative 13. So your answer is 0 comma negative 13 here. And you want 2 numbers that are next to this, okay? Now, I'm going to give you a hint here, and I guess this is a YouTube exclusive. If it's 3 comma negative 5 and you see A is negative 1 or negative 2, you could assume that the points next to it is going to go down 2. So I should expect my Y value to go to 3. Now let's see if that's true. Because this Y value is dependent on the A. So if you move 1, it goes down negative 2 in this case. That's not for every point. That's only for the points next to the vertex. So 3 was my x one. So we have what? 2 and 4. So let's plug in the first one. Negative 2. 2 minus 3 squared plus 5. Negative 2 times negative 1 squared plus 5. Negative 1 squared is positive 1. Positive 1 times negative 2 is negative 2 plus 5. Negative 2 plus 5 is 3. Hey, it's what I predicted. Same guy here. So over here we got, what is this, dude? 4. So negative 2, 4 minus 3 squared plus 5. Something's going to repeat because what happens is negative 2, 1 squared. And 1 squared is the same as negative 1 squared, which is positive 1. Positive 1 times 2 is negative 2 plus 5. Again, 3. So kind of my prediction, like I said, the A could help you figure out what the point is next. You could just subtract 2. The reason I don't mention that in normal class is simply because after that, it's a different thing. It's no more minus 2. It's going to be minus 2 squared, which is minus 4. And then after that, it's going to minus 2 to the 4th power, so it's going to be minus 16. So it doesn't keep pattern like that, and I don't want you to think of it like that usually. But it's a little hint if you're ahead of us, ahead of the curve. So let's see, 3 comma 5 is our curve. 1, 2, 3. 1, 2, 3, 4, 5 is our vertex, I should say. 2 comma 4, 2 comma 3, and then 5 comma 3. And like I said, is a negative guy, so he's frowning. There you go. Last one of the graphing. So this one, I think I remember I changed this one to just plain on your actual test because it didn't fit on the graph. I'm going to do this one for the points and just not graph it, okay? But I'm going to get all the points using this equation because it's still a good practice problem. So the vertex, to get the x of the vertex, you have to do, what do you have to do? Oh yeah, p plus Q divided by 2. You're getting the average of P and Q. Now notice the equation is negative P and negative Q, so you got to flip the signs. So P, in this case, is negative 4, plus Q, which is positive 2, over 2. That's negative 2 over 2. That's negative 1. So negative 1 should be here. That's your x value. Then we're going to plug it into here. So negative 3, negative 1 plus 4, and then negative 1 minus 2. Negative 3, 3, and this should be negative 3. So that is going to be a positive 27. So that's 27. Again, I'm not going to ask you to graph this because it doesn't fit in the graph. Axis of symmetry. And if, check your test, if I gave you an X on this, and if I gave you an X on this on your test, but put a negative 1 next to it, tell me, because I'll get rid of the negative 1. I might put an X with it, but not a negative 1. That means I didn't take away a point, just in case, because I basically gave this point for free due to my mistake. All right, axis of symmetry. So the axis of symmetry is the negative 1. The min-max value is 27. Is it a min-max value? Well, A over here is a negative 3, so it's going to be frowning. So that means you have a max value, so that's max. Y-intercept, so the y-intercept, where does it hit y-intercepts? Well, we have to plug in zeros. So negative 3 is 0 minus 4, and 0 minus 2, 0 plus 4, I'm sorry, and 0 minus 2. So that's negative 3 times 4 times negative 2. So that is going to be negative 12, negative 20, or positive 24. So 24, comma 0. Hey, look at this. Just want to point this out. Negative 3 is the A, and that's negative 1. One space away, so one space away, like I said last time, it's going to drop it by 3. So, hey, it dropped it by 3. That's one space away. But the 2 points. So what's good about the intercept form is you get 2 points for real easy. The 2 points is just negative 4, or P, comma 0, your roots, and 2, comma 0. Your roots, I want you to notice this is the same thing as in your next section, or next test. Is it next section? It's in the next section. These are your roots. This is where hitting the x-axis. This is where x equals 0. And if we were to graph it as best as we can, there'll be a negative 4 here. There'll be a 2 here. That's positive 2, comma 0. And it'll be like in the nether or whatever, all the way down here. And it comes back up here, okay? And it will keep going through. I don't want to pretend like it stops. Oh, been talking a lot. Oh, what is this? All right, solve by factoring. I'm going to go through this because it seems like a lot of you guys actually did this well. What multiplies to 6? That adds to 5. That's the basic game that we're playing. So what multiplies to 6? That adds to 5. There's only 2 things that multiply to 6, 2 and 3, and 1 and 6. 1 and 6 is 7, so that's not it. So it's 2 and 3, which is 5. So that's literally x plus 2, x plus 3. That's literally all you do. You pick the ones that fit with this. All right, this one, let's keep going. We have x squared minus 10x equals plus 21. It doesn't equal anything. Notice it doesn't equal anything, so we can stop right there. I'm talking about this question and these questions on the page. So 21, what multiplies to 21 that adds up to negative 10? Well, let's see. It's negative 10, so this is a little different. So 21, so 7 and 3 adds up to positive 10. But negative 7 times negative 3 still multiplies to positive 21, but adds up to negative 10. So this is the set you want to use. So x minus 7, x minus 3. That's your answer for that one. What multiplies to negative 30? So negative 30, to multiply to a negative number, you need one positive, one negative. So instead of adding to positive 1, you're kind of actually subtracting to positive 1. So we have 6 and negative 5, and negative 6 and 5. Let's see those numbers. 6 plus negative 5 is positive 1. Negative 6 plus 5 is negative 1. Well, I'm looking for a positive 1, so it's this set right here. So x plus 6, x minus 5. Okay, next one. Negative 33, that add up to negative 8. So we have 11 and negative 3, and negative 11 and 3. The top one adds up to positive 8, and the other one adds up to negative 8. So we want to use this one because the negative 8 is here. So x minus 11, x plus 3. I'm getting real lazy. Look at that. I just made one big parenthesis instead. All right, we're going to keep going. Oh, no, there's a 2 in front of here. What are we going to do? Well, we're going to do slide and divide. So first I'm going to slide it over here. So x squared plus 9x plus 20. Then I'm going to find what multiplies to 20. That adds to 9. Luckily, I'm a math teacher, so I could do it quickly. 5 times 4. So x plus 5, x plus 4. And you're like, oh, Mr. Tobel, am I done? Wrong. If you were done from here, I took off points. Because after you slide in the name, you have to divide. So we're going to do divided by 2, divided by 2. Now over here, this becomes nice and simple. X plus 2, because 4 divided by 2 is here. This one is x plus 5 over 2. That's a pain in the butt. We don't like that. We hate fractions, actually. No, I don't hate fractions, but I dislike fractions. So I'm going to move the 2 over here. So I'm going to do 2x plus 5. Box it. You want to, so technically it's not just slide and divide. It's actually slide, divide, slide, which is pretty interesting. It's actually an extra slide to it. Because any fraction you're left with, you want to move to the front, and that works out very nicely for us. Okay, these are special cases. So what's so special about them? There's only 2 terms, and it's perfect squares, both of them. So when they're perfect squares, is x plus 5, x minus 5. This is literally the easiest question on this test, and I hope you didn't get it wrong. Over here, it's again minus a square, so x minus 7, x plus 7. It's literally the easiest question ever. Please don't get it wrong again. This one over here, so we got 0 equals, now it equals 0. So what are we going to do when it equals 0? Luckily, exactly the same thing you literally did in the last test. So we're going to say what multiplies a 9 that adds a 10? Well, there's only 9 and 1 that adds a 10. So let's go. So x equals, I'm sorry, I'm stupid. So it's going to be x plus 9 and then x plus 1. But don't forget Mr. 0. He's been waiting on the outside of your room. So he's going to hunt you down. So this 0 is going to finish these guys off by doing something special, okay? So how are we going to do that, okay? As my camera does not focus for some reason. Focus on my hand. Doesn't focus on the thing. There you go. So what are we going to do? So we're going to split this and separate each one as 0 equals x plus 9 and 0 equals x plus 1. Why would you do that, Mr. Tobel? Well, here's the answer. If I make this number 0 and I multiply this, I don't give a care what this is, because if this is 0, then this is going to disappear, and I'm happy with that. So I have minus 1, negative 1 equals x. That's one of my answers, So that is negative 1. Over here, x plus 9. So minus 9, negative 9 equals x. Negative 9 equals x. That's my second answer. Why is that? Because if I plug in a negative 9 here, negative 9 plus 9 is 0. This becomes 0. 0 times, I don't give a care for what this is, will become all 0. So that's why we set each separately to 0. Next one, negative 10, that adds up to negative 3. Was this literally the same numbers on the last page? No, it wasn't. Okay, so negative 10 that multiplies to negative 3. You're doing the same thing. You're just pretending the 0 is not there until the end. So negative 5 and 2 is going to get me negative 3. X minus 3. I'm so crazy. X minus 5. X plus 2. That equals 0. Split. Do it. X equals positive 5. And I want you to notice it's the reverse of this. X equals negative 2. It's just the opposites. Hey, you know what else was the opposites? The PQs from 2 pages ago. The PQ from 2 pages ago. Look at that. Wait a second, Mr. Tobel. 4x plus 4x minus 2. That's like literally the same answers as we were doing here. Yeah, they're associated. They're the same thing, guys. I want you to know that. They're literally the same thing. I try to teach you that, and I hope that got through to you. All right, slide and divide again. X squared plus 10x plus 8 plus 24. What multiplies to 24 that adds up to 10? Oh, man, what is it? 6 and 4. Wow. So x plus 6, x plus 4 equals 0. But no. You got to divide. You slide. You got to divide. And you're going to have to slide again. So this is x plus 2, but this guy gets slid back forward, which is 3x plus 4 equals 0. Split solve. X equals negative 2. Good. X equals negative 4 over 3. I want you to notice 4 over 3, 4 over 3, 4 over 3, 4 over 3. Hey, that's actually your P, or your Q in this case, because we put it second. Whew, last test, thank God. We are almost there. Baruch Hashem, you know all that. All right, what's the square root of 16, guys? It's 4. What's the square root of 50? Oh, wait a second. Wait a second. That's not a clean one. So what are we going to do? We're going to simplify as best as we possibly can. So we're going to take that 50 and split it into factors. Let's do 10 and 5. And then I'm going to split this into 5 and 2. Uh-oh, there's a double here and here. These doubles get to escape. These doubles get to escape. So you have a 5 in front, square root. Anyone who's left over, which in this case is 2, is stuck in here. So 5 is the square root of 2. Any doubles get to escape. If you have a double, you're allowed to leave. If you don't have a double, you stay and get multiplied with all the leftovers. 2 is by itself, so 2 gets left over. This one, 99 and 3. I hope people realize it should be 11 and 9, which is 3 and 3. Okay, hey, we got double threes. They're running away. 11, though, didn't have a friend, so he gets to stay home. 11, 3 in front. Oh, it's very important to know, it's not 5 times 5 gets to escape. It's just normal 5. One of them gets caught along the way. Okay, square root of 24, so that's 6 and 4. That's 3, 2, and 2, 2. So there's a pair of 2's that get to escape, okay? So that's 2 in front, but the 3 and the 2 does not escape. So it's just 3 times 2. So it should actually be 2 root 6, okay? Sadly, a lot of people got this wrong, but it wasn't that complicated. I try to teach it differently, but then I charged it the same. It doesn't really matter. This should be an easy question. You guys should get this, okay? It's literally factor trees. Can you factor tree? Yes, you could do this. No? Well, what can I do? It's too late now. All right, rationalize. You know what's really nice about rationalization? You just multiply the top and bottom by root 5 over 5. Root 5. Okay? What's really nice is that it always looks like this. 3 root 5 over the number normally, which is just 5. Because think about this. Root 5 times root 5 is root 25. Root 25 is the whole number 5, so that's why I get to normal 5. I can do the same thing here. 10 root 2 over 2. The one thing, though, you could simplify this, and I would like you to simplify this, because if it was a multiple choice, it would look like this. Not this, but this. So make sure you know it can be simplified. 10 over 2 can be simplified. What's very important to know, though, which I don't think we learned until exponent rules, you cannot have this 2 interact with this 2, because this is under a square root and this is not under a square root. This guy's in jail and this guy's free. They can't interact. Only on visitor day. Next one. Oh, rationalize. Though. 5 over 2 plus root 3. We don't like that because we have to do the conjugate, which is 2 minus root 3. 2 minus root 3. So what does that imply? So we have the top and the bottom, and I'm going to do each one separately, okay? And I got to make sure it's on camera too. Okay, so the top part, which is 5 times 2 minus root 3. Well, you know what's really nice? You just distribute. So it's 10 minus 5 root 3. You're done with that. The bot, though, you're going to have to FOIL. Now, the foiling, I'm going to show you the shortcut because I already explained it enough times in real life, is 2 plus root 3, 2 minus root 3. Because it's exactly the same thing, and 1 is plus, 1 is minus, you could do 2 squared minus root 3 squared. Now, the square root and root is the opposites, so it just becomes 4 minus 3. 4 minus 3 is 1. So your answer is 10 minus 5 root 3. That's the top. 1 over 1. Okay? You don't leave it as a fraction, though. It would just look like this. 10 minus 5 root 3, okay? Because it's over 1, it's just that. Okay, we're solving for x. So when you have an x squared, you square root both sides. Very simple. X equals plus or minus 5. This is the one thing you need to remember. It's both positive and negative 5, so you got to put both down, okay? X squared plus equals 13, so we're going to square root both sides. X equals plus or minus. There is no clean square root for 13, so you just leave it square root 13. This takes less brain space than this one, because this one at least is plus or minus root 13. You don't even have to do anything. It's literally just that. Do it normally. X squared plus 5 equals 54. Minus 5, x squared equals 49. Divide square root both sides. X equals plus or minus 7. Don't forget the square root of 49 is 7. So when you have an algebra question like this, you got to actually add and subtract to both sides in order to solve it, because you want to isolate the x squared. So I'm going to do plus 10 first. So 3x squared equals 48. Divided by 3, x squared equals 16. Square root both sides. What's the square root of 16? That's right, it's 4. So plus or minus 4. We're almost there. Let's see if we could do it before 1:40. 1 hour and 40 minutes. Let's go. Next one. Ooh, simplified complex numbers. This is so easy. No one should get this wrong. It's straight up adding like terms. You've been doing that for only ever. So 5 goes with negative 3. What's 5 plus negative 3? That's right, it's 2. If you didn't know, you could use a calculator. 4i goes with 6i. Please look at the symbol in the middle. I had so many people who multiply it every time. It's not always the hardest possible question. Just look at the symbol in the middle. So 4i, 6i, that's plus. 4 plus 6, my gosh, is 10i. Let me get, it's good. Get that done. Oh my God, over here. 10 minus 2i minus 4 over 5i. So we're going to do 10 minus 4. That is 6. 10 minus 4. Make sure it's minus. Negative 2i plus 5i. Negative 2i. Oh, shoot. Plus 5i. So that's negative 2 minus 5i. That's negative 7i. That's simple, okay? Last one. We're going to distribute. 5i times negative 3 is negative 15i. 5i times 7i is plus 35i. Squared. Don't forget the squared. A lot of people forgot that. Oh, but what does I squared equals, Mr. Tobel? You're right. It is negative 1. Good job. So 35 times negative 1. So that's going to be negative 15i minus 35. Typically, we like the real numbers in front. I don't know. Like, I like my real friends over my imaginary friends. You like the real numbers over your imaginary numbers. Okay. Are we almost there? Why does this not focus when I hold this down? Hold it like this, I guess. Okay, that's much better. All right, I hope it wasn't blurry for most of the time, so let's keep going. Foiling. So 6 times negative 1 is negative 6. 6 times negative 3i is plus 18i. 2 times negative 1 is negative 2i. And 2 times negative 3i is negative 6i squared. Don't forget the squared. Combine like terms, and this I becomes negative 1. Don't forget that. So negative 6 plus, this is 16i. Let me just check if that's right, because what's this 16i? Negative, oh, this is negative 18. Because 6 times negative 3i is negative 18i. So anyone who wanted to correct me, too late, I corrected myself. So this is negative 18, this is going to be negative 20i. And I remember that from literally I remember it when I was grading it, so that's the only reason I actually fixed myself. Plus 6, because negative 1 times negative 6 is 6. Negative 6 plus 6, hey, that's 0. So that cancels out completely. Your final answer is negative 20i, which is pretty interesting. A lot of people put 12 or like negative 12 or something like that. You have to get rid of the I squared and turn it into a negative. 16, literally last question? Yes. Oh, Hallelujah. So we're going to multiply the top and the bottom by the conjugates. What's a conjugate? Well, it's like this, but what's different? Yeah, you're right. It's minus. So 3 minus 2i. Instead of plus, it's minus. So let's do it out. Top and bottom, I'll separate them because it's just easier like that. I'll just put, you know what? Funny enough, I'll put top on top and the bottom on the bottom. Just like that. So top is 7 times 3 minus 2i. That's straight distribution. That's straight algebra 1. 21 minus 14i. Easy peasy. Over here, the bottom, though. Oh, no, the bottom is foiling. But it's not even foiling because it's literally the same trick every time. 3 minus 2i. So we're going to do 3 squared minus 2 squared I squared. Okay? 9 minus 4 I squared. Hey, everyone, what does I squared equal? Yeah, that's right. No, it's not positive 1, but negative 1, okay? So this is negative 1 times negative 4. 9 plus 4 equals 13. Hey, you could do 9 plus 4. I could do 9 plus 4. Everyone could do 9 plus 4. Over. So let's put it as one big fraction, one happy family. 21 minus 14i over 13. You know what? I'm happy like that. Technically, you should technically write it as 21 over 13 minus 14i over 13. But I won't do that. That's not going to be the standard form. That's not going to be the way. That is the standard form, I should say. But it's not going to be the way on the test. So I would just take the first one. And I probably would give it to you like the first one. All right. We're done. Hope this helps. I got a little crazy at the end, but I hope that was at least entertaining. If you have any questions, you can always ask me in class, email me, communicate with me in some way. Don't ask me on the day of the midterm because I'm going to pretend I don't understand English on that day, and I'll let you guys take your test by yourselves. Of course, you don't talk during the midterms. No note card. The only formula I'm going to give you is the quadratic formula. Apparently, there was a misunderstanding on the test before I gave you the formulas, but on this midterm, I'm not. So make sure you know your formulas for your graphing, especially like those quadratics and the linear ones. You recognize what they are. It's not really a formula like you solve the formula. It's just like you recognize the parts of it. There's nothing else I can think for. I hope this video helps, and have a wonderful, wonderful midterm. And